Hello everyone. In this experiment, we are going to see how to interface a LCD to the ARM processor. To come to the hardware and software requirements, the hardware required for us is the 16x2 LCD. 16x2 means the LCD can display two lines of text with each 16 characters. That is what we mean by 16x2 LCD. So the hardware components are 16x2 LCD and the LPC 1343 ARM processor. And the software is the Cocox IDE. Coming to the program is quite simple for interfacing an LCD to the ARM processor. The first line, we include the header file for the LCD. This will include all the pre-required functions that are required to interface LCD to the ARM processor. This is the main difference between programming in LPC 1343 and other type of processors. The programming is quite simple and small when compared to a normal embedded C language. So if I just call the function lcd.h, the program, the LPC1343, knows what are the required internal functions to perform to display the characters onto the LCD. So lcd.h is the main header file for interfacing the LCD to the LPC1343 ARM processor. Next is the main loop. Initialize LCD is used to clear, or it is used to initialize the screen which will make the character from the starting place. So as I told you, it is going to be 16x2, two lines of characters of 16 characters each. So initializing will bring the cursor to the first point. LCD clear is used to clear already pre-programmed displays which have been displayed on the LCD screen. So if you've already programmed anything that was displayed on the LCD screen, to clear that particular program, we use the function LCD clear. And as I told you already, we can display two lines of characters. Like how we have printf statements in normal C language, we have the LCD underscore put string statement to display a text onto the LCD. So LCD underscore put string. In line 1, we are going to display some text called Rana, and in line 2, we are going to display some text called as LCD demo. So in line 1 in the LCD, we will be getting from the starting position as Rana, and in line 2, we will be getting the output as LCD demo. So we are initializing the LCD, we are clearing already pre-programmed internal files from the LCD, and in the next two lines we are writing what has to be printed onto the LCD display. And while of 1 is an infinite loop, it makes the text appear constant on the LCD screen without vanishing. This is the pin configuration of the LCD. As you can see, the LCD contains 6 pins. Pin number 1, 2, 3 and the last two pins 15, 16 are used for power supply and ground. So pin number 15, you can see anode, it is connected to power. Pin number 16 is cathode, it is connected to ground. And similarly, pin number 1, 2 and 3 are connected to the respective power and the ground pins. 4, 5, 6 are register select, read or write, this is W, read or write and enable. Register select is used to select the required registers. The LCD contains a set of registers for storing. So to select the required register, we use this register select function. The next pin number 5 is read or write. Whether we are going to read something from the LCD or we are going to write onto the LCD screen. Here we are performing the write function where we are printing some characters onto the LCD screen. Pin number 6 is enable. It is used to enable the LCD to work. It is like a starting function, start of the program or start of the display. Followed by this, we have a total of 8 data pins from D0 to D7. But to program a 16x2 LCD, 4 lines of data pins are sufficient. So we will be using the D4, D5, D6 and D7 pins. So how to interface this to the ARM processor? Pin number 1, 2, 3 and 15, 16 will be connected to the respective ground and power supplies. Pin number 4 will be connected to port 3.2 of the ARM processor. Read write to pin number 3.1 and enable to pin number 3.0. These are the pins of the ARM processor. Similarly, the 4 data pins has to be interfaced to the ARM processor. They are pin number 2.6, 2.7, 2.8 and 2.9. These pins are internally configured for the LCD. So when we mention the header file lcd.h, these connections will also be mentioned there. So it is required we have to give the same connections as I told here. We cannot interchange the connections. We cannot change the pin numbers. So it is 3.2, 3.1 and 3.0 for register select, read, write and enable, and 2.6, 2.7, 2.8 and 2.9 for D4, D5, D6 and D7. So this is how we interface LCD to the ARM processor in the hardware. And software, the programming part is quite simple. So once you interface the ARM processor to the LCD, we can get a required output like this. So this is a sample output. In Proteus, we will not be doing this interfacing. If in case we have a chance to do it in the physical lab, we will be doing it. But once you interface the required processor to the LCD display, we will be getting the two texts as Rana and LCD demo in the two lines like how it appears here. It will not be blinking, but it will remain static. The text will remain static because that is how we have programmed the text. So this is how we interface the LCD to the ARM processor. Thank you.